doing my problems now. Solve the following. So it is a rational exponent problem. Meaning I have that 4/3 equation. Get the, in this case, x minus 6 to the 4/3 alone. It already is. So I didn't really need to do that first kind of step, other than clearing the fractions. That's always the first step, but there are no fractions here. So what I'm going to do now is I'm going to raise both sides to the 3/4. Use the reciprocal power. The exponent I'm given is 4/3, so I use the reciprocal power and I raise both sides to the 3/4. So I look at that, my denominator is even. So we must include plus or minus. Because really, again, what I'm doing is I'll be taking the 4th root of both sides. And when I take an even power of both sides, I've got to include a plus or minus. So doing what I've said here, I'm going to raise both sides to the 3/4 power. Now, why this works, exponents to exponents, we multiply. And so this is going to give me very, very technically x to the first. Or excuse me, x minus 6 to the first. Now, I wouldn't expect anybody to show that step, but that's what's going on. Exponents to exponents, we multiply. 3/4, 4/3 times 3/4 is 1. And over here, getting ready to simplify, that's going to be the 4th root of 16 cubed. And so then I have x minus 6 equals. Now, you should know some of these basic other roots. But when you're asking yourself what is the 4th root of 16, you're asking yourself what number raised to the 4th power gives me 16. What number raised to the 4th power gives me 16? And that is 2. So I end up with plus or minus 2 cubed. Which gives me x minus 6 equals plus or minus 8, which is x minus 6 equals 8, or x minus 6 equals negative 8. And so add 6. And so we get x equals 2. X equals, no, that's not 2. X equals 14. X equals negative 2. But we have to check. And I'm just going to check this the old-fashioned way. I'm just going to plug in the original equation. So x equals 14. We had x minus 6 raised to the 4/3 equals 16. So 14 minus 6 to the 4/3. Wondering if that's going to be 16. That's 8 to the 4/3. Wondering if that's going to be 16. That's the cube root of 8 to the 4th. Wondering if that's going to be 16. Okay, again, these other roots. So cube root of 8. You're asking yourself what number cubed will give me 8. What number cubed will give me 8? And that'd be 2. And then indeed, 2 to the 4th is 16. So this guy checks. Doing the same thing with my other number, -2. Plugging in -2. And wondering if that's going to be 16. So I'm going to get -8 to the 4/3. Wondering if that's going to be 16. And so then that's the cube root of -8 to the 4th. Wondering if that's going to be 16. So again, we ask ourselves, what number cubed will give me a -8? Now I know some people are telling me I, there's something to do with an I here. But remember, square roots of negatives give you i's, not cube roots. Cube roots of negatives just give you negative answers. That's all it happens with that, and that's what's about odd roots. Odd roots of negatives just give you negative answers. And so no I here because this is a cube root. So we're just asking ourselves, what number cubed gives me -8? And that'd be -2, and -2 to the 4th is 16, and so they both check. Now, if you don't remember these basic roots so well, your calculator can do it. 8 raised 2, and then if you have an older calculator, so like this one's an older calculator, so it uses the exponent button instead of superscripting it, but then 2 divided by 3. That you got to be sure you put that exponent in parentheses, but your calculator will do it as long as you remember to put your exponent in parentheses, except it wasn't 2/3, it was 4/3. So there would be 8 to the 4/3. You do need to put that, if you have an older calculator, you got to remember to put that exponent in parentheses. If you have a newer calculator, an 84, where everything is already nicely neat in the exponent, you won't need the parentheses, but when in doubt, use parentheses. Extra parentheses generally aren't an issue. And you press enter, and we get 16. So your calculator can do these basic roots if you've forgotten those basic values there. And so there's that one. Okay, next problem. Okay, again, it's a rational exponent problem. Meaning we have that 5/2. And so the first thing I want to do is get the x to the 5/2 alone. So I'll subtract the 1 from both sides and get 2x to the 5/2 equals -64. Divide both sides by 2. And so I get x to the 5/2 equals -32. And then raise both sides to the reciprocal power. Raise both sides to 2/5. My denominator is odd. Odd denominator. No plus minus. It's when the denominator is even that I have a plus minus. Now notice the careful use of parentheses here. I want that entire negative number raised to the 2/5, so it has to go in parentheses. If you're going to use your calculator, that has to be in parentheses. Here, exponents to exponents, we multiply. So very, very explicitly, I get x to the 1st, and then that would be the 5th root of -32 squared. And so that's going to be x equals, and then you ask yourself, what number to the 5th power gives me -32? And that's -2. And again, if you don't know that, your calculator will tell you that. And I get 4. But I absolutely must check. I got the graphing checking down here. But let's do a quick old-fashioned checking. I got 4 here. So I'm going to plug into my original problem up here and cover all this up for a moment. So I'm going to plug 4 in there. 4 raised to the 5/2. Whatever that is, it's positive. So I got something positive there, times 2, still positive, plus 1, still positive. No way on this planet that that's going to be negative 63. And so just looking at it, this isn't going to check. 4 to the 5/2, that is actually 32, but it's positive. Doesn't matter what the value is right now, it's positive. So that's positive times positive 2 plus 1. Everything on the left is positive. No way it's going to be negative 63. That does not check. And so we only got that one potential answer, and so this has no solution. And then I checked it graphically, and I got a graph there, and notice no x-intercepts, which corresponds to the no solution. So either way you check, it actually comes out to be no solution. So very important that you check these. And that is rational exponent equations. So we got one last type of equations we're going to do in this section. And those are absolute value equations. So if you think back to what you learned about absolute value whenever you took math, absolute value of 8 is 8, and the absolute value of negative 8 is 8. So it's important to note that there are 2 values that can result in an absolute value of 8. This means that when we solve absolute value equations, we should expect 2 answers. Now, there is an official definition of absolute value. There's the official definition of absolute value. The absolute value of x equals x if the inside happens to be greater than or equal to 0. There's a tiny typo here. This right here should just be less than. And maybe someday I'll actually fix that tiny typo. It equals x if x is greater than or equal to 0. It equals the opposite of x if x is less than 0. The above definition shows that absolute value may be rewritten without absolute value into 2 expressions. And that's just what we're getting at here, how we're going to do these guys. It's going to be some rewriting that we have to get rid of that absolute value. If the inside is already positive, you get rid of the absolute value by just dropping it. If you know that the inside is negative, you're going to write the opposite. And so this is what's going to motivate to how we do the rewriting. That the absolute value may be rewritten that shows that the absolute value may be rewritten without the absolute value symbol into 2 expressions. One identical to the argument of the absolute value, and one the opposite of the argument. And by argument, we just mean the inside. So here's what's motivating what we're about to do. Now, you don't have to necessarily remember why we're doing what we're doing, although that'd be good. You'd be a better math student for remembering why. But you can get by just remembering why or doing what we want to do. So steps to solving absolute value equations. 1, rewrite isolating the absolute value. Make sure the absolute value is equal to a positive number. If it is not, stop. There is no solution because absolute value cannot equal a negative number. 2, rewrite without the absolute value symbol using the following format. Argument equal positive number or argument equal negative number. 3, solve each resulting equation. 4, check. And that's what we will do in the next video.